Okay, this is the IS-143 metal casting laboratory. What we're going to talk about today is casting these cylindrical bars for machining into the screwdriver blanks. We're also going to talk about how to make an individual casting, which is a little bit more complex. So what we're going to do is, this is called a match plate. The reason why it's a match plate because both sides are matched together, hopefully, so that this casting will come out and be round instead of shifted slightly. Okay? What we're going to do is we're going to ram sand that's been mixed. It has some strength to it against this pattern, and then remove the pattern, create a cavity, fill that cavity up with metal. Okay, in order to make this casting, what we're going to need to do is pick out a flask. The flask we're going to use for the bar castings are marked with the blue on the side of the flask, and you can see there's also marked somewhat blue on this pattern, so they match. Okay, what we're going to do is, the flask has two sides to it. The top part is called the cope, C-O-P-E. The bottom part is called the drag, because it drags in the ground. Okay? The drag always has the pins on it, okay, at least in the United States. Okay, what we're going to do is, we're going to put the pattern between the cope and the drag. Okay? And then we're going to ram the drag up first, and this is where most people screw up. They ram the cope up first, and then you have to flip it over to ram the drag up, and then you have to flip it over again to pour the metal into it. Okay, so you want to ram the drag first, because therefore you're not lifting that whole mold over again. Okay, we're also going to need a bottom board. You can see that this bottom board is painted blue as well, so everything is color coded. In order to make this mold, we're going to need some sand. So we're going to have to actually take some sand from underneath your actual bin and put it into the muller. Okay, the muller is in this wheelbarrow here, and what we're going to do is, this sand has clay in it. Okay, and clay doesn't, if you can see it here, when it's dry, it doesn't have much strength. If we add moisture to this, we're going to have some compactability. We're actually going to have to be able to mold it around our pattern. So what we're going to do is, we're going to lower the top of the muller that has the wheels in order to mix the sand into it. We're going to lower it onto here without cutting our hands off. Okay, that's the key words there, because you can see that everything on here is set up to cut your hands off. These little dogs here need to be lined up with this part of the muller. Okay, you see the dog is supposed to go down between there. If that is not lined up properly, the top will start to spin when you turn the muller on, because these big wheels are going to start to rotate and mix the sand up. How much sand should you put in there? About what you see here. Okay, about halfway full in the wheelbarrow. Okay, the crane hoist is pneumatic. It has an up and a down arrow. Okay, pretty straightforward. If I hit the up arrow, it goes up. Down arrow goes down fairly quickly, so make sure that no one else is right around this equipment. This is a very dangerous piece of equipment. This top part weighs about 500 pounds. You don't want it to fall on you. Okay, so we're going to lower this down, making sure it's lined up. You can have maybe someone on the other side help you line it up. If you push the valve halfway down, you try to make it go slower. Okay. Now notice that when it's all the way down, it still hasn't quite closed up yet. This is somewhat dangerous. If you leave this partially lifted, okay, in other words, if there's any tension on this chain, and you turn the muller on, it's going to drop down against that seam there. Okay, so if this doesn't have any slack to do that, the muller is going to start spinning around and creating havoc. Okay, and eventually it'll probably rip the cord out, which it did last time, and it turns itself off. But we don't want to see that because it becomes fairly dangerous. Okay, so you want to have a little bit of slack here on this hoist. We need to fix that. Okay, the second thing we're going to do is we're going to put water in here. And as this is mulling, we're going to add water to it. Okay? So I'm going to turn it on. It's plugged in over here. Everyone's standing away. See how it lowered down? Okay, I'm going to add the water. You can always add more water. You can never take any of the water away. So make sure that you wait for a while to check the sand. If it's got too much water in it, it'll turn to mud, and you'll hear that the motor start to make a different noise. It's very hard for the muller to actually mix the sand up. You might see it bounce around a little bit. That's an indication that the sand's either just getting ready for, or it's too wet. You can sort of see down in here if you look, just from one angle, and you can see if it's wet.
There you go.
Okay, so far we've added 2 cups and we're not quite there yet. We want to wait for at least 30 seconds to see if the water gets mixed in and if it's right, because it'll take a little while for the clay to become active. Okay, at this point I want to check and see if the sand's good enough for use. I'm going to turn off the muller. Okay, unplug it. And then what we're going to do is we're going to lift it up and don't stick your hand in there at this point. What we want to do is move the top part of the muller out of the way so that it doesn't fall in your hand. Okay? It's almost there. What you want the sand to do is to be able to squeeze it in your hand and not have any sticking to your hand. In other words, you don't want it too wet. It'll actually get mud stuck to your hand. So right now it's still a little dry, and it does have some strength to it, but not quite enough. We need to get a little bit more moisture in there. So just maybe another 1 cup. Once it gets real close to it, it doesn't take much to get it right at the perfect moisture level. Okay, we added a little bit more water. Let it mull for about 30 seconds. Okay, now it's perfect. It's got strength. Okay. Now you don't want to let the sand sit out for a half an hour before you use it, because the sand that's right on the top is going to lose the moisture. It's going to evaporate. So we want to use it right away. The best way to do this is probably in class. If there'll be about 4 groups working in the foundry at one time, you can put probably 4 people at each booth here. So what you're going to do is one group will be mixing sand while the other groups are working. Then you should trade off, because otherwise one group won't get anything done. Okay, it takes about 10 minutes or so to make a batch of sand. Then what you can do is you can dump it on the floor right over by one of the groups, and you can bring it over with a shovel. So. This should be enough for probably a couple molds or at least 1 mold. Let's put the whole barrel back together. Okay, at this point what we want to do is we want to add some parting powder to the pattern so that the sand won't stick to it. Okay? Don't put too much on, you'll end up drying out the sand. After that, you can take some sand, put it in the riddle, which is this sieve-like device, to take any impurities in the sand. You want the best sand to be in contact with the pattern. Okay, go ahead. Shake it back and forth and put a thin layer of sand on top of the pattern. Okay, after that, what you want to do is push it down with your fingertips in order to get good compaction around the pattern. The reason why you use your fingertips is because you want to compress it with a smaller amount of area, get more force per unit area then. Okay? Okay, after that, go ahead and shovel the sand Actually shovel the sand right in. Put it right in. At this point, we don't care if there's any particles of aluminum or whatever in the sand too much, but watch your hands. Take your rings and jewelry off as you're doing this. Okay, ram the sand around the outside first, and then back and forth across the center. Okay, do this in about 2 or 3 layers so that we get equal compaction. If you fill the whole flask up and don't make layers, you won't have a very hard mold at the bottom of it, and that's where it's important. The sand near the pattern has to be compacted the most. Spread the sand around, ram it up again. Use the pointed end of the rammer, okay? So that you get more pressure and so that the next layer of sand will stick to the previous layer of sand. Don't be afraid to pound on it, okay? Don't be shy.
You need a striker bar.
Okay, the last layer you want to use the flat end, and you don't have to kill it, okay? The reason for that is going to make it easier to cut the rest of the sand off. Okay, this is called the strike-off bar, and we're going to strike the sand off of the surface. That's why you don't have to quite ram it so hard. It makes it hard to pull the sand off the surface. Try to get most of the sand back into the sandbox so that you don't have to do quite as much sweeping at the end of the day. Okay, once it's totally struck off, what you want to do now is put a bottom board on it. And the bottom board is going to support the bottom of the flask evenly. Remember, you want to use the blue ones, and they might seem kind of small because they don't quite support the whole bottom, but you don't want to support the edge of the flask. You want to actually support the sand, not the flask. Okay? At this point, we're going to flip it over, and you should make sure that your bars on your table are the right width to support the bottom of the bottom board. Okay? At this point, we're going to put more parting powder on the cope side, and we're going to mold up the cope. Now, there's 2 ways to do this. You can if you look at your drawing, we want to put a sprue. The sprue is where the metal is going to come into the mold. We want to put that right about in the center of the mold. Okay? So, we can do one of 2 things. We can either put the sprue in there now, and here is the sprue cutter. We can set that in here and ram sand around it, or we can look and see where it is and ram it in later. It's going to be easier to do that. Otherwise, you got to hold this up while you ram the sand around it. Okay? So we can actually pound this down into there and cut the sprue. You want to use the sprue that's about 1/2 inch in diameter at the bottom. Okay? You can also use one that's tapered as well. You want to use the tapered sprue. So make sure you look at your drawing before you do this. Get wet sand. Throw that sand out. You want to get wet sand for the second time around. You don't want to use the dry sand from before. Pretty much the same process on the cope side. around the edge first, back and forth across the center. Okay, now that we remember exactly where that sprue goes, we can actually take and poke the sprue right exactly where it's supposed to go. Okay, you don't have to beat on this with a hammer or anything, it should go right in. If you want to go down, you can kind of give it a couple of wraps with a wooden rammer. Okay, make sure you get it all the way down to the parting line. Okay, at this point what we want to do is cut using a slick and spoon. We're going to, this is called a slick, that's a spoon. We're going to cut the pouring basin. And what that is where we're actually going to pour metal in here. The problem is we have someone that's trying to hit this little teeny hole with a big crucible filled with aluminum. Okay, this aluminum's got to get down that hole. So we want to make it slightly larger so it's easier to pour and keep that sprue full as they're pouring. So I'm going to cut it so that it's off-center to one side of the flask, and we've got to go the shortest distance to the side because we're going to be pouring over here, and the closer you are to the side, the better off you are. Okay? And also, it's offset so that the back of the pouring basin is parallel with the sprue right here. Okay, and the reason for that is so the metal goes in and goes straight down the sprue right away. Make sure there's no little chunks of sand adhering to the flask. Those will get washed into the mold. Okay. Go a little wider. Okay, at this point what we're going to do is we're going to pull the cope off and we'll have an impression where the pattern is. Then we're going to pull the pattern off the drag. Okay, so I'm going to take, and the easy way to do this, make sure most of the sand is off of the match plate. And I'm going to take and I'm going to push my thumbs and lift up on only the cope part. You don't want to lift everything up, you just want to lift the cope off. Okay, one thing you could do, it might make the pattern come out easier, is you kind of give it a couple of little wraps with the rammer. Okay. You got to go straight and together. It's one of those ones that sticks. Okay, I'm going to pull the cope off. Okay, not super smooth. Some of these flasks stick a little bit, so you might actually have to put a pry bar on there. But try to lift them up as evenly as possible off of the pattern. Now let's look at the impression and see that it came out pretty good. We have a little bit of a breakout at the end here. We can actually repair that with the slick. Okay. And we're going to machine this bar, so we'll be okay. Set it on there on the side. Okay, now what we want to do is lift off the match plate from the drag. Okay? Looks good. Okay, at this point what we're going to do is we're going to carve the gating system in. And we have to look at our drawing again to figure out how we're going to carve this. You can see that in the cope we have this thing called a riser. The riser is an extra reservoir of metal that's going to feed molten metal into the casting as it cools. If you don't have this riser of metal here, it's going to actually have shrinkage. The metal will be sucked down on top and you won't have a round bar. Okay? So this is one of the problems with casting, is that the metal shrinks as it cools, and we have to have these reservoirs of metal to feed the casting. And the whole idea is to have the solidification, or the actual cooling of the metal, start at this end of the casting progress toward this end of the casting. There's a lot more heat at this end than at that end. Okay, so the metal is going to come down the sprue, and it's going to go along in this runner here, into the riser, and through the gates into the casting. Okay, so these are gates. We got a riser, it's R-I-S-E-R, a runner, and a sprue. And we need to carve this by hand. So we're going to take our spoon again, and we're going to start carving. Okay, one of the things about these flasks is both the pins are round and both the holes are round. So that means that you can put this back together the wrong way. So it's not idiot-proof. What you got to do is remember how you took the cope off and how you set it down. Make sure you put it back on. It's very difficult with this particular mold to tell if you've got it on backwards because it's only off by about 1/4 inch. So if you put it on backwards, your bar is going to be shifted by 1/4 inch. Okay, so keep that in mind. So what we're going to do is we're going to take the slick, we're going to lay out where we're going to cut. Where we're going to cut out in the drag, we're going to cut a semicircular depression and these little gates here in the drag somewhat. And then we're going to cut out in the cope here, we're going to cut out the actual riser. Okay, we're going to go, about 3 inches tall. You don't want to quite go out the top of the mold though. So don't dig to China. Only about 3 inches, okay? So should be about 1/2 inch of sand left at the top. So go ahead and draw your gating system. And they have to match up, so make sure where you draw it in the drag matches up with where you draw it in the cope. It's kind of you can kind of measure over. You can use a ruler if you really want to, or just kind of measure with your thumb or whatever. Okay? Let me see. The other thing you want to figure out is where your sprue is going to come. The sprue is right about here. Okay? So we want to have your runner right about there. Okay? And we have to make a little impression underneath in order to slow the metal down as it comes into the mold. Go ahead and go ahead and carve. Okay, we have a semi-spherical base to our riser. Got nice, generous contacts in the drag, but also look at the cope. You got to make sure that your contacts are also in the cope, so that you have. The idea is that this metal, this reservoir that's in here, has to be able to flow into the casting. If it freezes right here, we won't have any metal flowing into the casting. Okay, so you don't want to have your casting freeze off. Okay, so what we want to do is blow the rest of the sand out. Make sure you blow the sand out of the sprue. You can kind of take the edge off the bottom of the sprue, so that none of that sand ends up in your casting. And I think we're ready to go. Our runner's in our drag. The runner is right here. These are the gates. And here is the bottom part of the riser. Metal's going to come in here, flow into the castings. It's going to start cooling here and work its way back towards the riser. That's the way we want to do it. Okay, I'm going to put the mold back together, making sure not to drop any sand on the open mold. And gently, we've got to make sure that this mold is completely closed. Some of these flasks bind up a little bit, so you want to look and see that you don't see any light between the cope and the drag. So make sure it's totally down. Okay? At this point, we're going to carry it over to the pouring floor, and we can pour molten aluminum into it. Okay? I'm going to demonstrate a loose pattern molding casting after this, and we'll pour both of these molds together at the end of the class.